Okay, the sine law is lesson 2, so we are no longer dealing with right triangles. I'm just going to read through the first paragraph. Last lesson we reviewed SOHCAHTOA, and again, that's only for right triangles that we can use the sine, cos, and tan ratio. Sine is opposite over hypotenuse, cos adjacent over hypotenuse, and so forth. So the next 3 lessons, we're going to focus on solving problems that are not right angles, So basically, where we can't use SOHCAHTOA. So in this lesson, we're going to try and solve an acute angled triangle. So basically, non-right triangle, where all angles are less than 90. Acute means less than 90. By 1, first we're going to look at a problem where we just split the triangle into 2 right triangles, and then second using the sine law. Now in class example 1, I've actually already done it to save time. So here's class example 1, okay? So what was given to us is that we know AB, which is 12.5 centimeters, and we know a couple angles. And what we're looking for is this line, BC. This is our unknown. And so already, because there's no right triangles, this would be a 70-degree angle. If we added our whole triangle, adds to 180. We have no right triangles. And so it's already been split into 2 right triangles for us. And so we basically have to work with each individual right triangle if we want to use SOHCAHTOA. So first, I solved for our opposite side here. And we did that using our 20-degree angle. The opposite side is what we're looking for, and we knew our hypotenuse, and so I used sine. Now the other triangle, we only knew an angle. We knew 35 degrees, but we did not know anything else. We didn't know the side of AD or DC or AC, and so I needed to find at least one side before I can find DC. And so what's in common between the 2 triangles is AD, line AD right here. Okay, that's what was in common. So what do we do? We found that side using our first triangle. And so again, I use the 20-degree angle here. And we want the adjacent side. And we have the hypotenuse of 12.50. And so using a cos, we found that adjacent side to be 11.46. Now, in our second right triangle here, this right triangle, we know 35 degrees and our opposite side of 14.76. So if we know those 2 things, now we can solve for side DC. Okay, so again, adjacent, we know, and we know opposite, that's the tan ratio. So tan gave us our side DC, right, 16.775, and we already know side BD. So together we can add them together to get our full length of DC, which is equal to 21.05. A lot of work, okay? Extremely a lot of work here to find one side. So is there an easier way to do that? And that's where the sine law comes in. The sine law is made for triangles that are not right, and we're going to prove it in a moment. The first thing you need to know is when we label vertices, we use capital letters. Capital A, capital B, capital C are the most common. Now the sides are going to be with lowercase letters, and it's going to be opposite to that vertice. So side A is opposite of angle A. Side B is opposite of angle B. And side C is opposite angle C. Okay, so there's our sides. Now the sine law, it's pretty easy. It looks like this, and we're going to prove it in a moment. A over sine A is equal to side B over sine of B equals C over sine C. And we'd use one of those ratios when we're looking for a side. So if we're looking for a side. If we're looking for an angle, then we just flip the ratio. So we change the formula to be sine A over A equals sine B over B which equals sine C over C. Now, of course, in the actual problem, we're only going to set two ratios equal to each other. We don't want to use all three at once. We don't need to. Okay, so when do we use the sine law? Well, we can only use the sine law when an angle and its opposite side is given. An angle and its opposite side is given, and we know one other piece of information, whether that be an angle or a side. And one other piece of information. So an angle or a side. And so what happens is it becomes an X situation. If I was, say, looking for side B, this is my unknown, and I knew angle A, and I knew side A, and I knew angle B, then we could use the sine ratio. It's always going to become an X situation. If I was looking for side B then, and I know side A and angle A and angle B, I would use this ratio. And so we're going to often make this X. Let's look at your notes for a moment. So in your notes, remember that opposite side A is opposite angle A is side A, opposite B is side B, and opposite angle C is side C. So let's prove the sine law. We do that by splitting it into two right angles and using SOHCAHTOA, specifically the sine ratio. Remember, the sine of an angle equals opposite over hypotenuse. So let's complete the work that's done here. So they start by saying sine A is equal to, here's its opposite of CD over its hypotenuse, which we actually call little b. Little b. Okay? And we're going to need to actually label little a. Little a is right here. Little a. All right, so little a, which is also on the other triangle. We already have this as little a, and here's little b. So it's the same situation, same lengths. Okay, so CD, if we rearrange the formula, we'd multiply both sides by little b, and so CD is b sine a. So let's set up a similar situation. Sine of b is our opposite of CD over our hypotenuse of little a. And so sine b, so you could also write that, or instead of basically they were saying AC or BC in this step, which is the same thing as CD over little a. So we call BC little a. And so if we want to solve for CD, we multiply both sides by a, and so we get sine a times sine b. Okay, so if we know CD is equal to b times sine a and CD equals to a times sine b, then we can set them equal to each other. So b sine a, that transitive property that we use in the other unit, is equal to a sine b. And if we just rearrange the formula, so divide both sides by sine a sine b, that gives us the following result. So it's really just about rearranging the formula. So I divide this side by sine A sine B, divide this side. So what we do to one side, we do to the other. Then what happens is our sine A's cancel out over here, our sine B's cancel out over here, and we're left with the formula B over sine B equals A over sine A. And a similar proof can be done for the C part. You do not have to prove this, you just need to know how to basically use the formula. So let's practice using the formula. So when do we use this? Well, we have to know three pieces of information. Specifically, we need to know one angle and its opposite side. So you know its angle and opposite side. So looking at example 2, do we know an angle and its opposite side? Ooh, yes, we do. Remember, it's like making that x. We know an angle and its opposite side, and we need one other piece of information. We know angle A, so we could find its opposite side. We're going to make an x. Okay, so let's label our triangle. If we know this is little c, or angle C, opposite is little c. And if we know angle A, opposite of it is little a. You could even put the little b there if you want. So we want to find, it says find BC. We want to find little a. So if we want little a, let's do our circle. We have to know its opposite angle, and we know at least one side in its opposite angle. So we're going to set up the formula like this. Because we're looking for a side, little a, that's going to go on top. So a over sine a equals, and we know c and sine c. So we're going to write c over sine c. This is on your formula sheet. So your formula sheet, here they are. Okay, you don't have to memorize them. It's there, although the sine law is so easy that you will probably know it by heart. So now we fill in. So first step is always writing your formula. Remember to do that on your test. Then we substitute. So a is our unknown over sine 75 degrees equals c, which is 12.50 over sine 35 degrees. Super easy. And all you need is one step here. Why? We're looking for a. It's being divided by sine 75. So what are we going to do to both sides? Multiply by sine 75. Cancels, and there we go. So in your this should becomes a is equal to, so it comes on the new 12.50 sine 75 divided by sine 35. So with your calculator, make sure you're in degree mode. Remember how to check to see if you're in degree mode. We push tan 45 and it should equal 1. So typing this in, I have 12.5 times sine 75 divided by sine 35. And that's that easy. So 21.05. That's an identical question that I looked at before. Look how much easier that was. It's incredible. Such a great formula. Okay. So let's look at another example. It says use the sine law in the triangle shown to determine angle ACB. So angle ACB is this angle. We want that angle. Remember that we need to know at least an angle and its opposite side. So I know angle A and little a is 9.4. Because I know side B, which is AC, right, opposite of angle B, then I can only start by solving for angle B. But if I knew angle B, could we get angle C? And the answer is yes. If I knew this guy, remember that the three of them are going to add to 180. So we're going to start by solving for angle B. So let's label our triangle. We know side A and we know side B. And I'm looking for an angle, so instead I'm going to write sine B on top. So sine B divided by little b, and we're dealing with a, so sine A over little a. And that's also on your formula sheet. So now let's sub. Sine B is what we're looking for, divided by little b, which is 6, equals sine of 110, because angle A is 110 over 9.4. We're looking for sine B. Right now it's being divided by 6, so we're going to multiply both sides by 6. Multiply both sides by 6. That cancels. I like to put the 6 in front of the sign, so I know I don't type it in properly. So 6 sine 110 over 9.4. So we're going to type that into our calculators. Oops. So in our calculators, 6 times, well, even if you put the 6 after, I'll show you. So if I did in front, 6 sine 110 divided by 9.4. Or you could have typed it as 9, like the second step, sine of 110 divided by 9.4 times 6. Either's fine. Now, is that our answer? So I have sine B equals 0.5998. Sine B equals 0.5998. We want angle B, not sine of B. So how do we get rid of sine B? We take the sine inverse of both sides. The inverse sine. And then these will cancel. So angle B is sine inverse of 0.5998. So in your calculators, remember that second sign, we can just go second negative for our answer. And now that's to the nearest degree, 37 degrees. Angle B is 37 degrees. We're not done though, because we were looking for angle C. And so angle C is 180 minus 110 minus 37, which gives us 33 degrees. So now we're done. There you go. One more question and we are done. A surveyor measures a baseline PQ to be 440 meters long. 440 meters long is PQ. We're going to call that little r, actually, instead of PQ. He takes measurements of a landmark R from P. So he measures R from P and Q and finds that angle QPR is 46 degrees and angle PQR is 75 degrees. It says calculate the perimeter of PQR. So that means we need to know both side little q and little p because we want to add them all together for perimeter. So where do you want to start? Well, we need to know at least an angle on its opposite side. Well, I only know the side R, so that means I need to know angle R. Because we know the other two angles, we can solve quite easily for that angle. 180 minus 46 minus 75 gives us 59 degrees. So now I know an angle on its side. And we can go ahead and solve for side Q or side P. But we're going to have to find both. So let's start with side Q. Side Q. So that's the first x we're going to use. So Q over sine Q is equal to R over sine R. Because we're looking for a side, we're going to put the side on top of the numerator. So Q over sine Q equals R over sine R. Oops. R over sine R. My angle just got caught off. Sorry, it's 59 degrees here. Okay, subbing in, Q is unknown. So leave that as Q over sine of Q. Sine of 75 equals R. Little r is 440 meters over the sine of R. Sine of angle R is 59 degrees. Okay, so we're looking for little q. It's being divided by sine 75. So let's multiply both sides by sine 75. And so little q is going to equal to 440 times sine 75 all over sine 59. On your calculators, 440 sine 75 over sine 59. And there is q. 495.83. 495.83. And meters. Okay, so now we've solved. So now we know that little q is 495.83 meters. Let's find p. It's always good to use the given information, so I'm still going to use r and sine r, and then we'll use p and sine p. Because I'm looking for p, p is going to go in the numerator. So p over sine p equals r over sine r. And p over sine of angle p is 46 degrees. equals r of 440 over sine 59. And one more time, we're looking for p. It's being divided by sine 46. So we're going to multiply both sides by sine 46. These cancel. And this is what we're going to type in our calculator. 440 times sine 46 divided by sine 59. Very easy. Sine law is probably one of my favorite. Probably even easier than SOHCAHTOA. So 440 sine 46 divided by sine 59. And there you go, 369.25. 369.25 meters. And so last, what's our perimeter? Well, our perimeter is the sum of all three sides. So 440 meters plus the 369.25 meters plus 495.83 meters. Adding that all together, and they want us to round to the nearest meter. So in my calculator, plus 495.827.7844. I'll use my exact values. And the 440, we still need to add to that. The nearest meter, two pluses. We only got one. 1,305 meters is our perimeter. There you go. And so the homework for this is 1 through 9, but you can omit 6b.